Hello everyone and welcome to Ganthead's presentation, Agile Estimation, Key Principles and Practices for Successful Agile Projects. My name is Andy Jordan, President of Refenzian Consulting Inc., and I'll be the moderator for you today. Ganthead is the world's largest online community for IT project managers, providing articles, blogs, downloads, deliverables, forums, and a social networking component. Ganthead is designed to educate, make your jobs easier, bring people closer together, and foster the community spirit. Today I'm delighted to be joined by John Clifford, Senior Fellow of Construct Software. I'm just going to introduce John and allow him to take over, but before I do, just a couple of minor housekeeping items. We do have a period for questions at the end of the presentation, and please feel free to use the chat window in the Citrix session so that you can ask any questions during the presentation, and I will be asking those of John at the end. John is a Senior Fellow at Construct Software, where he focuses on software development, project management, and team management practices with an emphasis on Agile practices. Prior to joining Construct, he worked for small startups and software behemoths as a development engineer, a product feature team manager, a group QA manager, group project manager, and development director. With more than 3 decades of IT experience, John has developed software for CPM, Unix, VAX, VMS, NVSTSO, macOS, Windows, and Windows CE. His expertise is both deep and wide, ranging from desktop, mobile, and embedded device applications to frameworks and asynchronous telecommunications software for microcomputers and mainframes. John has led successful organizational transformations to Agile and holds the Certified Scrum Master, Certified Scrum Product Owner, and Certified Scrum Practitioner certifications from the Scrum Alliance. John, thank you for joining us today, and please take it away.
Thank you, Andy. Good morning, everybody, or good afternoon, depending on where you're located. We're going to talk about estimation today, and more specifically about estimation in an Agile context. Although Agile estimation techniques may be different from what you're used to, the principles we'll discuss apply universally. We'll start by defining what an estimate is, and more importantly, what it isn't. Confusion around this is one of the 10 deadly sins in software estimation. Next, we'll discuss why we estimate, keeping the principle of beginning with the end in mind. Estimation is done for a purpose. We also need to know when to estimate and when to stop estimating. We'll discuss this in the context of return on investment, estimating until we have received the necessary value at each particular stage of our product development lifecycle, and then acknowledging that further effort expended on estimation will not return sufficient value given our current state of understanding. Are accurate estimates precise estimates? We'll talk about the difference between accuracy and precision, how to tell the difference, and which attribute is more important. Hint, it's not what you think. The cone of uncertainty is a useful model for understanding how we know and what we don't know. It affects our ability to derive value from estimation and other planning activities. Because most software-related projects involve significant amounts of uncertainty in terms of what we're trying to do and how we should go about doing it, we have to be able to accept uncertainty. Especially, but not exclusively in an Agile environment, we need to be able to determine efficiently what can and should be done based upon what we know and can know today, and we also need to be able to accept that we can proceed once we obtain a minimally sufficient understanding of what is needed to be known today versus what we can defer until our knowledge increases in our wicked problem space. Continuing on our agenda for today's webinar, we'll talk about the difference between estimates, targets, and commitments. This is especially important in the context of realistic, achievable project schedules. Confusion across the organization on what we're discussing or who owns what often leads to unrealistic project plans with over-optimistic schedules, a surefire recipe for project disaster. After all, we have a reasonable chance of success based upon a realistic schedule, but no reasonable chance of success with an unrealistic schedule. Then we'll get to the details of Agile estimation, starting with the basics. We'll talk about fundamental estimation principles that apply to all projects, whether or not we're using Agile development and project management practices. And we'll discuss the faulty assumptions that result in ineffective estimates despite our best efforts. We'll delve into story points. What are they? Why do Agile practitioners use them? And how to create accurate effort-based estimates using story points. Then we'll move into an overview of release planning and how to develop a realistic project schedule for your Scrum projects based upon the key principles, practices and techniques we've covered prior to this part of the webinar. Using what we've learned, we'll go through an example exercise where we actually determine accurate, realistic project duration and cost estimates based upon realistic sample data, similar to what our clients actually developed during constructs-led release planning workshops. And finally, you'll have an opportunity to participate in a live question and answer session, as Andy mentioned earlier, at the end of the webinar. Let's begin with the essentials. What is an estimate? Here's a dictionary definition: an approximate calculation or judgment of the value, number, quantity, or extent of something, whatever that something is. Tom DeMarco, the noted software engineering practitioner and consultant and author of Peopleware and Waltzing with Bears, has a tongue-in-cheek definition that seems to be popular among those optimists for which hope is the primary project management strategy. An estimate is the most optimistic prediction that has a non-zero probability of coming true. How many times has your management only accepted the best case estimates, or taken your estimates and arbitrarily reduced them in order to shorten the schedule? How well has that worked? All of this has led to many people believing that estimation is something that might as well be done under a full moon or on a bubbling cauldron with some Eye of Newt thrown in when you consider the results we most often get from our current practices. That there is no such thing as an accurate estimate, that the term itself is an oxymoron, like benevolent dictatorship or bug-free software or code complete. They're wrong, but their cynicism is understandable. If you are also cynical about ever seeing accurate estimates for your projects, let me urge you to take one step away from cynicism over to a healthy skepticism, because I think you'll be convinced that accurate estimation is something that is not all that hard, given that you understand the principles behind the practices. Our goal today is to ensure that accurate estimate will no longer be considered an oxymoron, and neither will on-schedule project. Why do we estimate? We estimate to determine what we will do next, to make a decision. Do we approve a project or choose something that is more feasible? Commit to the proposed spent backlog or remove some items or add some items? Go on to phase 2 or kill the project now before we waste more time and effort? The best decisions are based upon hard evidence, data, not speculation or hope or guesses. Accurate estimates give us the hard evidence to make effective decisions. In the software project space, we estimate in order to determine our capabilities in terms of scope, schedule, and budget. We do so because our business wants us to make realistic commitments that we can keep. They want us to be predictable, to deliver what we said we could, when we said we could, at the cost we said it would. The business makes commitments around our project commitments, and if we fail, we impact the business. Predictability is the most important aspect of project management. In fact, we manage projects in order to obtain predictability, because without it, we are just whistling in the dark, spending the company's money with no discernible result. The business leaders hate that, and who can blame them? Because we often aren't as predictable as the business demands, the obvious conclusion, although it's probably not the correct one, is that we failed because our estimates were incorrect. Therefore, the thinking goes, we need to do a better job of estimating, which means that we need to spend a lot more time on it. On the next project, project managers insist on better estimates from engineers. But what does better really mean? It should mean more accurate estimates, but too often it means more precise estimates. And that is exactly what we can't get at the beginning of a project, even if we double our estimation effort. All that extra time is waste, and the mistaken belief that it's better to be precise than accurate, and so we end up being precisely wrong instead of approximately right. Repeated failure leads to increasing effort doing the wrong thing and a vicious spiral of increasingly onerous, increasingly ineffective process and ceremony. So maybe it's not that we're doing it wrong, it's that we're doing the wrong thing at the wrong time, using the wrong approach, because we can't know enough at the beginning of a project to be precise, even though we can and do know enough to be accurate. Most software projects are attempts to solve wicked problems, problems that are not fully defined or well understood, and we cannot fully define and understand them until we spend sufficient effort learning about them as we actually try to solve them. The effort return curve is a great way to visualize a trade-off between how much work we do to obtain estimates versus the value we get. Most of the value in any type of planning, whether it's estimating, requirements analysis, design, etc., comes fairly quickly because we know what we know without having to exert ourselves. And we generally do know the important things about our projects, the big things, fairly early in the planning phase. So we get a lot of value for our effort early on. After a certain point, when we've exhausted our knowledge in the wicked problem space, we're going to have to get our hands dirty and start trying to solve the problem to obtain more understanding and get past the uncertainty. Think about it as it applies to another type of wicked problem, fixing a car that won't start. Doing will help us discover what it is we don't know, and more doing will lead us to learn the details and devise the correct solution. If we can't get the car started, but instead insist on more of the same type of planning activities, such as turning the key over and over again, we won't gain any knowledge. And similarly on our projects, if we insist on more of the same type of activities, including planning, estimation, that we've been doing, we really don't get any more knowledge about our project. So we'll learn more about our problem, whether it's trying to start a car or trying to learn more about a project, if we start working rather than keep on turning the key. So the solution here is to stop thinking about the problem itself when we expend more effort than the value we receive, when the value and effort ratio drops below 1. Okay, and start doing, realize that by doing well, doing it, we will in fact also be learning, discovering, reducing the uncertainty. The doing effectively steepens the curve again as we gain new knowledge. And as you can see, we get a lot of bang for our buck initially, but as we double our effort, we don't get double the return on it. So how do you know when you've hit the point of diminishing returns? In the Agile world, if we can't easily think and discover what we know, it's time to stop thinking and start doing. For instance, when we estimate remaining duration of sprint tasks during sprints, as we update our status in Scrum on a daily basis, if we spend more than 10 to 15 seconds thinking about how many hours remain on a current task, we're probably spending too much time. So the key here to managing uncertainty is to never fool ourselves into thinking we know more than we actually do, that we're more precise than our knowledge indicates. Admitting what we don't know allows us to estimate accurately while acknowledging our uncertainty. All estimates contain uncertainty, whether it's implicit or explicit. Precision, or the relative level of granularity, should reflect that uncertainty. For instance, a project duration estimate of 2 to 4 quarters doesn't have the same implied precision as a half year, or 6 months, or 26 weeks, or 180 days, or 1,040 man-hours, or staff hours. Yet if the project takes 6.5 months, which one of those estimates was more accurate? Which ones were accurate at all, and which weren't? Here's the key to answering that question. Accurate estimates have a range that contains the actual value of the something we are estimating. In the example above, our initial 2 to 4 quarters estimate was accurate. 6.5 months lies within the explicit range. Implicit estimates like half year imply a range of plus or minus 1/2 to 1 of the unit of measure, or again somewhere in the idea of 3 to 9 months. What about 26 weeks with its implied plus or minus of a week? You can see that the more precise estimates were not accurate. The range did not include the actual value. Now I can imagine a large number of you just sat up in your chairs in outrage. How can you say that 26 weeks was inaccurate when the project came in at 28 weeks? That's almost on the nose. I will grant that most business folks would be ecstatic if we could always be plus or minus 2 weeks on predictions for projects that take around half a year. But the reality is that perhaps this project is one component of a larger program or product release, and the overall schedule has a critical path with its dependencies all charted out. What happens to that overall schedule when a project on the critical path slips 2 weeks? Remember, anytime something on the critical path slips, every dependent item downstream also slips. More important, we generally build project schedules by accumulating all of the task estimates through bottom-up estimation, and we generally schedule tasks to start and end on specific dates based upon our calculations. If every low-level estimate is similarly inaccurate, off by a couple of days, then the slippages accumulate, and we can't make it up by taking advantage of the occasional early finish, because most of our resources are not available for early starts due to other commitments on our projects. If you are familiar with critical chain project management, the mechanism it uses to take advantage of early finishes is to ensure that early finishes never occur by manipulating schedule durations as necessary. We get the same effect, the implementation of a pull system in just-in-time task scheduling, by the more straightforward mechanisms of swarming, limiting work in progress, and fixed sprint commitments in Scrum. To summarize, it's better to be approximately right than precisely wrong. But too often we spend additional wasted time trying for precision instead of accuracy in the false belief that one is the equivalent of the other. And then we create unrealistic schedules based upon inaccurate but precise estimates. Is it any wonder our schedules are off? Here's another example, straight from a popular TV show. Imagine you're the key advisor to the President of the United States and you've just learned of a highly contagious outbreak of a disease in a suburb of New York City. The government has sealed the borders of the state and now needs to know how many dosages of a vaccine will be needed to ensure public safety across the state of New York. Your first estimate is between 10 and 30 million, based upon your basic knowledge of New York State, an estimate with a ratio of 3 to 1 between the high and low values. You know it can't be more than 30 million. You're pretty sure it's not less than the population of New York City, so you feel pretty good about your estimate. But the president gets on the phone and says, I need better information. We only have 30 million dosages on hand of our vaccine, and we can't send it all to New York because the vaccine deteriorates rapidly once out of storage. And what if the contagion has spread to a neighboring state? We need a reserve. Get me a better estimate. We think. We know that the state's population can't be more than 2 to 3 times the population of greater New York City. Does that narrow things? Not really. It's still about a 2 to 3 to 1 ratio between our high and low values. So let's go to the internet. But it's down due to the crisis, so we're on our own. Drat. Next, we remember seeing that the population of New York State is approximately twice the population of New York City, and we mentioned this. Another advisor on the phone offers 20 million, plus or minus a million, because I know that's twice the population of New York City. Is that a more accurate estimate than the original 10 to 30 million, or is it more precise? We finally advised the president to order 21 million dosages, and he does, and the crisis is averted. Eventually, we learned that 19,378,102 doses were utilized. That final estimate of 20 million plus or minus a million was accurate and precise enough to prevent wasting a large amount of the vaccine. What if we said, order 19 million? Taking the best case estimate in an attempt to be more precise in our knowledge actually allows us at the time would have resulted in the deaths of hundreds of thousands of people and billions of dollars of expense, while taking the worst case may have cost a few $1,000,000 in wasted vaccine dosages. Certainly a rational trade-off. Do we fail to make the same rational trade-offs in our projects? Maybe I should say, don't we fail to make the same rational trade-offs? By the way, that last number of 19,378,102 people was the official U.S. Census population count as of 2010. Would anybody on this webinar bet $1 that the official population of New York City was accurate for more than a few minutes during the entire year? Especially considering the birth and death rates and immigration and expmigration of people from the city? Is there a reason for the precision of the estimate? Or is the Census Bureau just fooling us and maybe fooling themselves as well? Because of the way in which we present our estimates and the range we provide, whether implicit or explicit, communicates our level of knowledge to others, it's crucial that you choose a granularity that matches your level of uncertainty. Maybe you'll estimate projects in terms of team months, features in terms of t-shirt sizes, such as small, medium, large, backlog items in terms of story points, and component tasks for those backlog items, things that are done by individuals to implement the backlog items, in hours. Regardless of the exact units, use the right level of precision to correspond with your level of uncertainty. How do you know what your level of uncertainty is? This is where the cone of uncertainty can be very useful. The cone of uncertainty is a metaphor for understanding how our precision varies based upon where we are in our project, because where we are in our project correlates to our level of uncertainty at that point in time. Uncertainty and risk are two sides of the same coin. The more uncertainty we have, the more risk we face. We increase our range and therefore reduce our precision in order to obtain our accuracy. Doing so reflects our uncertainty and the risk it presents, because time really is the only tool we have to manage risk, whether it's adding a schedule buffer or adding more people to our project in an attempt to add more staff hours to the day. It's interesting that the initial reaction that many well-intentioned but uninformed managers have when seeing this kind of uncertainty represented in the early stages of a project, and it's reflected in large estimates and ranges or buffers, is to arbitrarily reduce those estimate ranges or remove those buffers from our schedules in order to provide the appearance of pulling in the schedule dates. There, they say proudly, I've shortened your schedule for you, as if removing uncertainty from a project schedule removes uncertainty from a project. Instead, what they've done, and all they've done, is to remove our ability to effectively manage the uncertainty. Oops. At the very beginning of a project, at exception, when all we have is a product vision and maybe a one-page high-level list of desired functionality, we really don't know enough to be able to estimate with any precision. And the ratio of our best case to worst case here could be up to a 16-to-1 difference. In other words, we might go to our managers or stakeholders and say, based upon this vision and this one-page sheet of functionality, we can confidently predict that this project will take anywhere from 1 to 16 team months. Now that's an accurate estimate, but it's not precise. At the beginning of the planning phase of our project, when we've already done some work, perhaps having developed the skeleton of our story map with users and high-level features identified, our increased knowledge and reduced uncertainty should allow us to narrow that cone and reduce our estimation range to about a 4-to-1 ratio. Then we can say to our stakeholders, this project will take anywhere from 3 to 12 team months. Still accurate, but more precise as we narrow the range. At the end of the planning phase, when we're ready to proceed with our first sprint, when we have a fully populated and estimated product backlog hanging off of our story map skeleton, and we've identified the subset of the backlog that comprises our minimum releasable functionality, or MRF, then we can tighten our estimate range to about a 3-to-1 ratio while still remaining accuracy. Now, based upon our latest information, we can estimate that this project will take between 6 and 18 two-week sprints. Still accurate, even more precise. Now, even a 3-to-1 ratio may be unacceptable to management with a traditional approach to projects and commitments. So what would happen if you went into a project approval process meeting and told your executive team that your best estimate for this project was between 1 and 3 years to deliver? The proper thing to do here is not to offer a more appealing answer by disregarding the cone of uncertainty and reducing the range arbitrarily. You don't remove uncertainty from a schedule by removing uncertainty from a schedule. Instead, you get your stakeholders to let you effectively buy an option on your project, much the same way that investors buy options on stocks or commodities, and for the same reason, to reduce risk. It's a hedging strategy. And we do this by having the team run 3 sprints to get a much better handle on how long the project will actually take, because they have an accurate velocity figured out. And then we can tighten the project duration estimate considerably, down to a 1.5-to-1 ratio or better. Now you can go back to your executive team and report, based upon our 3-sprint velocity moving average, we predict 7 to 11 sprints of completion, with our logic duration being 9 sprints of completion. Still accurate and very precise. We're talking about, what, 4/11ths difference here, or really a 2/11ths difference, or about 20% after a rapid and inexpensive planning phase, plus 3 team sprints with the project cost. And the beauty of using historical data to improve our precision is that our estimation of our project duration gets more and more accurate and more precise as we proceed through the project. The business can now look at the expected return versus project cost and make rational, informed decisions at every step with go-to-go decisions based upon real data, not guesses. Risks are greatly reduced because clearly unrealistic projects can be canceled early before sinking a lot of money into them. We fail fast on bad projects, and we can commit to achievable promises on the others, and the business gets the data they need for effective project governance. Speaking of commitments, it's crucial that everybody understand the difference between estimates, targets, and commitments, and who is responsible for what. Mistaking estimates for commitments is one of the 10 deadly sins of software estimation. An estimate is a judgment of the amount of work that has to be done, and by derivation, the time required to do that work. Estimates are the responsibility of the technical organization, and specifically the people who do the work. Only the supplier of the estimate can legitimately change it. Targets, the desired values for scope, schedule, and budget, are properly the responsibility of the business sponsors. This is what we want in terms of functionality, this is when we want it, and this is how much we want to pay. Those who want the project and who will be funding it have the right to set the targets. Commitments are mutually agreed upon and result from negotiation between the technical organization, who fully believe they can fulfill on the commitment, and the sponsors, who accept that commitment and who can live with it. A business that disregards estimates and dictates commitments to the technical organization is setting itself up for project failure. Nothing is less likely to be achieved than a commitment that is set by someone else without regard for the opinion of those people actually doing the work. So if arbitrary setting of commitments is so ineffective, and it clearly is, why does it happen? Why is it the norm in our industry? I believe it is a telling indicator of a lack of trust that exists in the majority of companies, and that lack of trust is being created by the fact that software projects are rarely delivered on time, within budget, and with the desired scope and quality. But that lack of trust is caused by behavior by both sides, the technical organization and the business folks. If we're going to get better at delivery, we can't keep planning and executing our projects using methods and practices that clearly don't work. The definition of insanity is doing the same thing repeatedly and expecting different results. We've got to get off that insanity loop. So we can start the process of improvement by going back to the basics. A key rule of estimation, regardless of whether or not you're using Agile practices, is to estimate effort and derive duration. In an Agile environment, we estimate effort in terms of story points. We can think of story points as akin to distance, as if we were runners, and we were looking down a long road to figure out how far it is to that sign. We estimate velocity, or the rate at which we can implement functionality, in terms of story points per sprint. Back to the running analogy. Velocity would be how fast we can run down to that sign, maybe in terms of how many minutes it takes to run a mile. So once we have estimates for effort and velocity, we can derive duration by a simple calculation of sprints to completion, which is equivalent to the total number of story points representing all the work in our project divided by our velocity, which gives us the number of sprints to completion. Again, back to the running analogy. If the large highway sign is approximately 1.5 miles down the road, and we can run a mile in 7 minutes, our project duration, or the time it would take us to run to that sign, is about 10 minutes, or between 1 and 2 sprints. Let's focus on story points, what they are not, and how we can represent them on an Agile project. Story points are an arbitrary relative measure of the combination of size, effort, or complexity for a particular backlog item. I use the term arbitrary because we assign our original number arbitrarily to a reference story that we will use as a yardstick to make the relative comparisons for other stories in order to size them accurately. I use the term relative because when we look at two stories and their estimates in terms of story points, we can draw conclusions based upon the relation between the estimates, but we can't draw conclusions looking at a single number by itself. For instance, if one story is a 10, that tells us nothing. But if we look at two stories and one is a 10 and the other is a 20, we are saying that we believe the 20 will take twice as much effort as the 10, and given a constant velocity, will take twice as long to implement. So now let's talk about what story points aren't. They most emphatically aren't a measure of duration. We can derive duration based upon velocity from story points, but story points in and of themselves have no relationship to absolute time. Just as saying 1.5 miles has no relationship to the time required to cover that distance without taking velocity into account. We can obviously run 1.5 miles quicker than we can walk it. We can ride it on a bicycle quicker than we can run it. And if we're in a car, we're much faster. The velocity is what's different, not the distance. And because story points are by intention imprecise, the Agile community has coalesced around using arbitrary numbers to represent effort. And in particular, the Fibonacci series has become a widely adopted numbering sequence for several reasons. Chief among them is that the Fibonacci series has an interesting property. Once you get much above 2, each number in the series is approximately 60% of the next higher number and 160% of the next lower number. Another way of saying this is that there is a bell curve that centers above each number and ends at the next upper and lower numbers in the series, providing a built-in range of 60% to 160% on our estimates using the Fibonacci series. So why story points? Why not ideal hours or staff days or some other unit of measure? First, any use of a unit of measure that has some relationship to time, even if it's theoretical, such as ideal time, will allow people to start thinking about time when they estimate and not effort. The result is that teams will want to increase their estimates to reflect uncertainty of the time required, and if this is allowed during sprint planning, the malaise of story point inflation sets in. The two symptoms of story point inflation is that scope looks like it's increasing, and velocity may or may not look like it's increasing. Unfortunately, teams often use the new larger estimates as a reason to fail. Well, this was a larger story, so of course we couldn't get it done, but our velocity is still the same. In reality, the team is going backwards. To all Scrum Masters who are listening to the webinar, don't let teams re-estimate backlogs that have already been estimated during sprint planning. Velocity will handle the variations in productivity. Second, there will never be more than 24 hours in a day, at least not on this plan. How can a team measure velocity or improve it when they can't add hours to the day? just as you can't run further in a minute by changing how many seconds are in a minute. However, we can use story points estimation to determine our velocity, and then use changes in velocity to determine whether our process changes are effective or not, whether they're increasing our velocity and productivity. If we are, in fact, getting faster as we become more fit in our ability to deliver software. And as we mentioned earlier, the built-in range of the Fibonacci series lets us take advantage of the law of large numbers to ensure our overall estimate of the amount of effort in the project is very close to the actual amount. We'll go into more detail on the law of large numbers and how it applies in a few minutes. Finally, the fuzziness of the Fibonacci series keeps us from getting wrapped around the axle, spending too much time refining our estimates unnecessarily. If we estimate one story as a 5, when maybe in real life it's a 6, it's a little bit more than a 5, so we'll call it could be a 6, let's say. And then we estimate another story as an 8, when in reality it's a little bit less than that, let's say a 7. The total is about the same. 5 plus 8 is 13, 6 plus 7 is 13. We can count on the law of large numbers to protect us. So how do we use this to estimate a project backlog? First, we pick one backlog item that the team has some understanding of and agreement on in terms of effort. A good story to pick initially at the very beginning of this process is one that we think will take about half the team, about half the time. In other words, you should take half the number of people on your Scrum team, about half the sprint to implement. Now, this is the only point in which we will think about time during the estimation process, selecting that first initial reference story. Once we've identified the reference story, we can assign an arbitrary Fibonacci number to it. Say 21 or 34, it doesn't really matter. What we don't want to do is to go too large, like 89 or 233, because it will encourage us to be too granular on smaller stories. And we don't want to go too small, like a 1 or a 3, because it will be very hard to estimate smaller stories. We especially don't want to go with a 5, because that will often persuade people who are new to Agile estimation to think in terms of weeks, because they map 5 with 5 days. Next, for each backlog item, we ask a very simple question. How does this compare to our reference story in terms of effort to implement? Let's say the reference story is a 21, and we think the story is about half the work. Now, there is no 10 in the Fibonacci series, so we have to decide whether the story is an 8 or a 13. So we talk about it a little bit and say, you know, it's really not quite half. So guess what? 8 it is. We repeat this process for all the backlog items, pausing occasionally to compare different items to each other, and not just to the reference story. So we can keep estimation drift, which is the tendency for estimates to start wandering from the standard, to a minimum by these quick back-of-the-envelope calibration checks. The key here is not to spend significant amounts of time estimating. Your estimates will be off, but they will not be off by an order of magnitude. More importantly, they'll be consistently off. And you can verify this to your own satisfaction by considering what happens with estimation today in your projects. Are you over half the time, or are you under half the time, so your projects generally come in over half the time and under half the time? Most likely, you're like most companies, and you continually underestimate in an over-optimistic fashion, and your projects are always late. So there you go, sitting up in your chair again, shouting, again, how can this possibly work? Now we get to talk about the law of large numbers and how we'll step in and save us. The law of large numbers is really very simple. As the number of estimates we make increases, the sum of our estimation errors will approach 0. In short, the estimation errors cancel each other out. Because we're using a Fibonacci series, we will have estimation errors by design due to the built-in range as described earlier. As long as we have enough backlog items to estimate, our number of samples is large enough, and it really takes no more than a couple dozen items in a backlog, we'll be in good shape. Does it really work? Yes, it does. So as a quick example, many teams actually track, find and fix rates on defects to the end of their project to see how they're doing. And they find that their teams average a certain number of bugs fixed per day per developer. And it's amazing how constant that trend applies across an entire project. Now, why does that trend apply? Because the law of large numbers also applies to that. Some bugs may take 3 days to fix, some bugs take 30 minutes, but the average is a pretty surprising constant across a team, across a project. Here's another example. How do elevator companies know how strong to make their elevators? They use a law of large numbers to determine the average weight of adults and also the average area or footprint, how much elevator floor space is occupied by the average person. Then they size elevators to ensure that elevator capacity cannot reasonably be exceeded by the number of people who can actually fit inside it. And of course, I'm sure they add a little safety margin. The key is to have enough backlog items to make the law apply. If you have 5 items in your backlog, you don't have enough samples. If you have a couple dozen items, you're good to go. So I have another sample example looking at story points for travel. I've gone ahead and estimated the distance between several pairs of points on and near the Earth using the Fibonacci series. So I can say if I fly nonstop from LA to New York, it's about 2,500 miles. So let's call it a 3 because it's more than a 2. Next, I want to go to Sydney. Now that's about 8,000 miles, give or take, so I'll call it an 8. Now I want to fly around the world at the equator because I'm feeling adventurous and I've got all these frequent flyer miles. That's about 2,400 miles, give or take, maybe 25,000 miles. And the closest number I can come up with in the Fibonacci series is a 21. Now, for some reason, I have a magic airliner, and I'm going to fly to the moon because I've never been there. It seems like a cool place to go to. That's about 240,000 miles. Again, my closest Fibonacci series number is 233. So if I add up all my story points, I get 265 points worth of effort. And now if I map this to the actual distances, which are 2,449 miles from LA to New York, 7,497 miles from LA to Sydney, 24,909 miles from around the Earth at the equator, and 238,850 miles, the average distance from the Earth to the Moon. The total is about 273,697, or about a 3% difference. Again, if we took that difference and extrapolated to a project with fixed velocity, then we would derive, and we derived our duration from that, and we said it would take about a year. The difference, that 3% difference, is about a plus or minus of 2 weeks. Would you be satisfied to be plus or minus 2 weeks on a one-year project in terms of knowing the effort for the entire scope? Because we understand that the estimation should most properly be done by the people doing the work, and in an Agile context, that means all of the people, we want the team to estimate backlog items. And we want them to estimate by consensus, not coercion. We want them to agree because they agree, not because someone says this is what it is. So wideband Delphi is a traditional estimation technique that relies on a team of individuals estimating separately, sharing their answers with a disinterested third party who collects those estimates, and then broadcasts them back, and then repeating the cycle until consensus is achieved. We do something very similar to Agile projects by using planning poker, and the heuristic is very simple. We simply discuss the estimation, the backlog item as a group, and then we use planning poker cards that we can make up by printing numbers on Post-it notes or index cards, or we can run them off on a printer, whatever works. The simpler the better. Okay, so everybody prepares their estimate individually and privately, perhaps by putting it under the table, putting their hand over their number, or just thinking about the number but not actually picking it out. And then at a agreed upon signal, everybody reveals their estimates simultaneously, and then the team discusses the difference, the outliers. And we repeat that process until we come to consensus. Ideally, we want to use historical data if all possible because it's the most accurate estimation reference. If your team has previously worked on an Agile project with a properly estimated backlog, select reference stories from that backlog to use against a new project backlog, and now you have built-in calibration. If your team has established a velocity figure based on that previous project, then you're way ahead of the game. And you should be able to have a very accurate and precise estimate starting off. Project backlogs and team velocities from other teams in your organization may be helpful to give you some general guidance, but don't overly rely on them. It may be simpler and more effective to start your own project out and quickly gather velocity data after a few sprints. Having valid historical data to decrease the effort of estimation and greatly improve our accuracy and precision is a very good reason to keep our teams together across projects. So how do we estimate velocity with a newly created team on a new project, and perhaps in an organization that is new to Scrum? Start with an estimated project backlog if at all possible. Okay? And then with that backlog, have the team start at different places and think about how many consecutive stories they could do in a sprint. After 3 or 4 samples through the backlog, you can start getting the average number of points by adding up these samples and doing the dividing by the number of samples. And that will give you an idea of what the team thinks they can do. Remember, because the team is new and the process is probably new as well, and because the team is also probably not used to getting it done in a sprint, their estimates will most likely be optimistic. They think they can get more done than they probably can. But it's okay because we're going to account for that. Okay? We'll treat that average that we just developed with samples as the optimistic upper bounds of our velocity estimate, and then we'll divide that number by 2 to get the pessimistic lower bounds estimate. And we'll consider going even lower for a new team. And finally, we want to take that lower bounds estimate and make the team agree and acknowledge that they are 100% sure that there's no way they can't get things done at that velocity. And once you get a figure like that, you've got an effective lower bounds. Keep in mind that new teams will need 2 or 3 calibration sprints to get a real effective velocity. Okay, and you also have to educate your business folks so they understand that commitments before we get that valid velocity can be accurate, but they can't necessarily be precise. So they're far better off giving us some time to get that information in. Okay, if we seem conservative, remind them that we'd rather under-promise and over-deliver, because not many people get fired for coming in early. Well, let's use what we've learned to do some estimate of a project plan using some sample data. Now, this data is actually pretty similar to some real planning that I've done with companies that we've worked with recently in release planning workshops. So after story mapping and backlog creation, we've identified 520 points of scope in the project with the minimum releasable functionality, which is the minimal scope we need across all the features for this release, coming up to 378 points. So we've got to get the green scope. We'd like to get the red scope. Okay. Similarly, after taking our samples through the backlog, the team believes that its best case velocity is 42 points per sprint. We've reduced that accordingly and got the team to agree that there's no way they can't get at least 20 points per sprint. They would bet their jobs on it. So now we have a best and worst case velocity figure. The engineering organization has decided to run 2-week sprints in order to increase agility and to use that pressure as a forcing function to get the team to improve more quickly. And the product owner has looked at the overhead costs by looking at the employees on the team and has figured out that each sprint costs us $40,000 in burden costs, including overhead. Now we have all the inputs we need to do effective project planning. So we take all this information and we run it through the project planning sausage grinder and see what comes out. Our best case scenario in terms of project duration would be to be able to release after getting that minimum releasable functionality all completed. The minimum we need to actually release at the highest velocity, which is our best case velocity. And our data shows that the best case would take 9 sprints of completion or 18 weeks. Our worst case, we'd have to do all the scope, not just the MRF scope, with the team running at the worst case velocity. So our data shows this would take us 26 sprints or 52 calendar weeks. A good rule of thumb for an initial prediction, not a commitment, is to assume we can get by with implementing only the MRF scope, but we do it at the worst case velocity. So our data shows that would take us 19 sprints or 38 calendar weeks. So now we have an estimated project duration of between 9 to 26 sprints, with our initial prediction, not commitment, to be about 19 sprints. Now, if we have to commit at this point before we know more, then the only realistic safe commitment is to promise that we can get it all done in the worst case. We'll give you the minimum scope in the maximum time. In other words, we'll give you MRF functionality in 26 sprints. Now, that commitment may not be what the bosses want to hear, but it is correct, and the correct response is not to fold and be cautioned into making an unrealistic promise. Instead, we should tell the business, yes, we understand it's not what you want to hear, but this is the best we can do to be accurate with what we know today. We can give you a more precise commitment if you give us 3 sprints. We can also use a duration estimate to come up with project cost estimates, but keep in mind that there are other considerations as well. Okay? How much time is actually available for work versus ideal time? People take vacations, get sick, etc. So let's say your organization has 3 weeks of vacation, 10 days of sick leave, and 10 paid holidays, then you've lost 7 weeks out of your year already. So you can incorporate this into your predictions by using the ratio of availability as a coefficient of velocity. For example, using our estimate of 7 weeks out of the year lost, then we would take the reciprocal of that and or we would multiply that fraction by our velocity. So for instance, we would take about 60% or 50% off our velocity, and about 60% would be added to our durations across the board and to our costs as well. So I've got the ideal figures here without that additional coefficient figured on. Again, our best case at $40,000 a sprint times 9 sprints would be $360,000 for this project. Our worst case is 26 sprints at the same $40,000 per sprint, which is $1.04 million. Our initial prediction, 19 sprints, brings us to about $760,000. So it's good to show these to our stakeholders and see if we're in the ballpark for their expectations. Some quick reminders. Remember the cone of uncertainty. Commit only to MRF by the calculated dates before you have an effective velocity figure. And recalculate your project velocity after each sprint, okay, based upon both the last sprint velocity and upon a 3-sprint moving average to smooth out variations. Base your commitments on your projects on demonstrated performance, not initial estimates. A reasonable commitment requires at least 3 sprints worth of velocity data or an intact team that has an established velocity from previous projects. Educate your organization so they recognize the benefits of letting your team spend less time planning and more time actually running sprints to get valuable historical data. And keep in mind that learning organizations use the power of the sprint retrospective to increase their velocity through the project. Scrum Master should understand that a team with a stable velocity over several sprints is a team that's no longer learning how to deliver software better. Don't let inertia become an impediment. So we've covered some key principles and practices for estimation on Agile projects as part of a series on improving our ability to successfully deliver projects by following 7 simple steps. Work with your customers to understand what they actually want. Keep in mind that customers don't often know what they want, and even if they do, they often can't express this to you effectively. Create accurate effort-based estimates instead of precise duration-based estimates. And then make realistic plans based upon those estimates, but make your realistic commitments based upon demonstrated performance. In other words, promise only what you have proven you can deliver. Empower your teams to leverage the collective wisdom of your organization. Focus on delivering the highest value as early as possible. You will always run out of time before you run out of scope, so do the most important things first. Do one thing, do it well, and finish what you start. Getting things done is the only way to work successfully on a project. And finally, obtain constant feedback on your progress, on your product, and your process, and act upon that feedback to improve in all 3 areas. The only failure in Scrum is failure to learn. Thanks for attending this webinar, and please stand by for the live question and answer portion.
John, thank you for that. That was an amazing presentation. We already have a number of questions which I'll get to in just a moment, but for everybody's benefit, just to let everyone know that there will be a link to download the slides as well as a link to the on-demand recording of the webinar, and that'll be emailed to you at the conclusion of the event. If you do have any questions now, please type them into the chat window and just hit send, and we'll get to as many as we can in the few minutes that are left. John, let me just start with a nice easy one for you. There's a couple of people have asked you just to expand a little bit more and explain the term MRF and MRF scope.
Sure. Let me explain MMF first. MMF means Minimum Marketable Feature Set. And this is a term that was developed by the authors of a book called Software by Numbers, written in the mid-90s. And the concept is that with every function, there are some attributes of functionality, with every feature, there are attributes of functionality that must be made available in order for the feature to have value to the customer. And there are additional attributes of functionality that would be nice to have, but we can ship without it. And so that when we talk about MMF, we want to prioritize our scope so that we do the must-have attributes of functionality for a feature first, and then if we have time, we'll do the nice-to-have attributes of functionality. And so if we think about the MMF concept as applying to a feature of a product that we're doing or a project that we're doing, MRF, or Minimum Releasable Functionality, is the aggregate of MMF across every feature we need for our release. So each feature has MMF functionality. The total of minimum marketable features set functionality across all of the features comprises minimum releasable functionality. Once we've implemented those items, we could deploy if it was required by the business.
Thanks, John. One question here that I think is probably something a lot of people can relate to. Bruno asks, how do we accurately estimate velocity when the team's not 100% dedicated and each team member may have a percentage of their allocation split amongst a couple of different teams?
That is a great question. And I'm going to give you a simple answer, which is it's going to be very difficult to do that, if not impossible. Scrum does not like to have teams split up, and again, it's not just a Scrum rule, it's a general rule of effective working. If there's a saying in the Bible that no man can serve 2 masters, and I think that reflects perfectly in the situation you're describing. If I'm on 2 project teams, can I realistically make commitments to both teams? Because if I do, one team will suffer for the other. And so it's far better to have people assigned to teams 100%, or if we know they're not going to be assigned, we need to take that into account. And what will happen then is the teams will have much lower velocity than they should theoretically be able to have, and that cost of bandwidth, that cost of velocity, is the cost of having an ineffective organizational setting. But one of the real reasons that we split people across teams is because we move people to work, and instead we should move work to people. Keep people on the same teams, and if there is a backlog item that only they can do, assign it to their team's backlog so they can pull it into a sprint and work on it.
That makes sense. Thank you. A couple of questions from people around scale, and taking a slightly different angle to it, but let me ask the 2 questions together because I think it's a nice pairing. Chris says, how can this apply to scaling the team? He says his boss wants to double the size of the team and expects that by doing that, that will double the velocity. We all know the dangers of that one. And then the opposite end of the spectrum, Andrew says, is there a way to apply this on a small scale? He says he's working on a project of one developer taking just a small amount of time, about 2 weeks worth of work, but how can he improve the accuracy of his estimates at that small scale?
Okay, those are two great questions. And let me tackle the first one about doubling team will double velocity. That's one of those assumptions. It seems like it would be logical, but it's not. And the reason is because the larger teams get, the more communications overhead we have between people on the teams. So rather than doubling the team, create a separate Scrum team. To have two teams, not one large team. So Scrum has a rule for sizing teams, and the good size for a Scrum team is 7 plus or minus 2, between 5 and 9 people, not including the Scrum Master or Product Owner. If you do that, then it's a lot easier to manage things, and you probably will see a doubling of your velocity, given that you have the same general capabilities across both teams. Now back to the second question, how can an individual do this? Well, I'm a big believer in that valid principles scale, even if practices don't. And so I can actually, as an individual, use a Scrum-like process called the Pomodoro technique, where I can estimate my work items not in terms of story points, but in terms of Pomodoros or units of sprints that it would take me to do them. So effectively, it is like a story point. So by doing that, I can keep track of what's going on. And there's a general rule of any kind of process. The more you do something, the better you're going to get at it. So if I start estimating and I track them, not so that a manager can judge me, but I can use it for my own personal improvement, I will find that I will get better and better at estimating the actual amount of work that something takes. So I would encourage individuals who are working to create a backlog, which can be as simple as a task list that they have to work on, and estimate it in terms of just, if they want to estimate in terms of just raw ideal hours remaining on the item, and keep their original estimate and then just track how much time they spent on it as a personal improvement thing, not something that management would judge them by, I'm all in favor of that. In fact, that's the key to the Software Engineering Institute's personal software productivity program.
And I think that's key, John. I mean, it's not necessarily about, it's not at all about keeping management happy. It's about improving the overall quality, and that's as much about our personal experiences and gains as it is about keeping the management off our backs.
Sure.
We've got a lot of questions, so let me just get straight to the next one. Margaret's got a management challenge, John. She says she manages 3 development teams, and their estimates are different. The management wants to see one combined velocity per iteration across all 3 teams, but because the estimates are different, adding the 3 together just isn't adding any value. Margaret's trying to understand how she can get the 3 to estimate similarly, and wondered if you had any suggestions to help her out on that.
Yeah, that is a great question. And what I often do when I work with multiple teams on a larger project and scaling them is I work with key people on all the teams and get them to agree on setting a common reference story or reference stories. So we may get the backlog created, and then as we estimate, we may take that core group of people so that represent all the teams or each of the teams and have them agree on a reference story and say, yes, we'll agree that this reference story is a 21. And maybe we might have 3 stories. One is a small, which might be an 8, a medium is a 34, and a large is an 89. And those become our references that each team can use, and when they come up with their own estimates, they should compare them to the reference. So in other words, if I say something is a 21, I mean it's about 60% of a 34, and that should apply across all the project teams in a project. And by doing that, it helps us normalize our velocity across teams. Again, not as a comparative thing to judge one team against another, but so we can accumulate each team's velocity and get what I call a project velocity.
Okay, that makes perfect sense. Thank you. Tremendous number of questions, so I apologize to people who've asked questions that we're just not going to get to, but I'll try and get to a couple more if we can. Ted is asking about velocities again. You've definitely hit a nerve with velocities on this one. How do you determine the worst case velocities?
Well, as I mentioned in the webinar, I will let the team do those samples to get a best case, and I'll divide it by at least 2. But my final answer to that is I will put a figure up there, and we'll look at the backlog, and I want the team to not to tell me that they could try and get it done, but to have absolutely no doubt that they could get the minimum velocity done in the sprint. Absolutely no doubt. And usually when we're first starting out, it's a pretty conservative figure. I've seen some teams divide their expected case by 3 to get that worst case. And so maybe they're going to do 1 story a sprint as their worst case. Again, starting out on a project, when we have no experience and no historical data, having a 3 or 4 to 1 ratio is not that bad. And especially when we remind our stakeholders that give us a couple of sprints and we'll narrow that range considerably. So I always tell people a statistic of 1 is useless. We need to get a trend. And by running several sprints, we'll get that trend. So people shouldn't panic, when they first see this number. If they might want to say to themselves, if the worst case is totally unacceptable, then are they willing to pull the plug on the project in 3 sprints if we can't run faster? Because that's a valid question to ask also.
Okay, let's try and squeeze one more question in. Ken says, and this is a question I'm sure many people can relate to, how do you handle situations when MMF equals absolutely everything?
That's a great question, and that points out a deeper problem, and that problem is that the product owner or the stakeholders that the product owner represents are unwilling to prioritize. And again, if everything's important, nothing's important. Product owners have to be ruthless about prioritization. And I've worked in the same situation where people say, no, you don't understand, it's all got to be done. And when push comes to shove, you know that things will be cut if you run out of time. So the secret is to cut them now so we don't spend time working on things we're never going to ship. And we can actually probably get more done if we start with that approach. What I've often done when working with recalcitrant product managers who don't want to cut scope is I let them dot vote. So if we have 13 items that we have to get done in 6 months, and the team knows that they only get 7 of these items done, but the product owner will not prioritize, I'll give that product owner, here's 20 votes. Vote for what you want. You can put them all in one, you can start out or whatever, and that can often make the product owner start recognizing what is really important and what isn't.
John, I can't thank you enough for your time today. This has been a tremendously valuable session. I very much appreciate it. If our audience wants to learn more about constructs, they can go to www.constructs.com. That's CONSTRUX.com. And I'd like to thank everybody for taking the time today to join us and GANHead for this webinar. And please come back soon for the next GANHead session. Thank you, everybody, and have a great day.
Thank you, everybody.